Okay, class, for the 8.6 lesson, we're going to be discussing the area um, of a trapezoid, or maybe you want to say the space inside of a trapezoid. Um, we're going to start out this lesson um, by going right to number 2, okay? Um, and if you want to think about this in example 2, I'm going to try and simplify this here. What I first want you to recall is that here we need to recollect how to find the space inside of this trapezoid. Okay, excuse me, parallelogram. So we got parallelogram A, B, C, D, and in order to find the space inside of a parallelogram, it's going to be area equals base times altitude, or maybe you want to say area equals base times height. Okay, so I want you to recall that from the 8.5 lesson, how to find the area inside of a parallelogram. Shaded in red, there's our parallelogram ABCD. To find a space inside of that is area equals base times altitude. Now, a couple things, okay? And I want you to imagine, okay? I want you to imagine if we took scissors and cut right through that black segment. You need to now realize that the quadrilateral that I'm highlighting, okay, now in green, is called the trapezoid. We're calling that a trapezoid is a parallelogram that has one pair of opposite sides that are parallel, okay? So we now have a trapezoid, a green trapezoid, inside of this one parallelogram. And in fact, if we focus on the other side now, we have another one of these trapezoids over here, upside down. So actually, this green trapezoid and this blue trapezoid make up the area of the parallelogram. Okay? So two things are happening here. First, knowing that it's true that the space inside of a parallelogram is area equals base times altitude, and now we know that we have two congruent trapezoids inside one parallelogram. If I now ask you what has to be true, or how do we manipulate the area formula for parallelogram, if I asked you to find the area, let's say, of the blue trapezoid or the green, they're both congruent, it doesn't matter. So let's focus on just one of the two trapezoids because they're both congruent. Well, if I say, how do we find the space inside of the blue trapezoid, or what has to be true about the area of the blue trapezoid in relationship to the area of the original parallelogram, hopefully you would notice that, well, the area of that blue trapezoid or the green has to be 1/2 the area of the parallelogram. Why? Because two of those trapezoids fit in the one parallelogram. So we need to take this formula for parallelogram and we got to cut it in half because the area of that green trapezoid or the blue is 1/2 the area of that of the parallelogram. Okay, next. I'm just going to rewrite this formula backwards. Okay, now I want you to imagine taking scissors and cutting right through this black segment, separating the green trapezoid from the blue trapezoid. And hopefully you would notice before you cut through the black segment that the length of the base of the parallelogram is DC, or if you want to look at it from the bottom, the length of the base of the parallelogram is segment AB from the bottom, if you will. So if we cut through that black segment and separate the green and the blue trapezoid, no longer do we just have B for base, because now we have two bases, if you will, for the trapezoids. Part of our original parallelogram base is in green and part of it is in blue. So to get back to the base of the parallelogram, we need to add the two bases. So manipulating this equation a little more, instead of B for base for parallelogram, when we cut through the black segment, creating the two trapezoids, we now have to add those two bases. get back to the parallelogram. And now we've actually arrived at the formula for how to find the area or space inside of a trapezoid. It's the altitude times the quantity of base 1 plus base 2 divided by 2, or we could write it as 1/2 altitude times the quantity of base 1 plus base 2. Let's do some examples. Okay, remembering two congruent trapezoids fit in one parallelogram, so the formula for trapezoid should look similar to the formula for area of a parallelogram. Okay, so we have the altitude times the quantity of the sum of the two bases divided by 2. Okay, or I'll write up here, you may like to write it as this: area equals 1/2 times the altitude times the sum of the two bases. These two formulas are two and the same formulas, whichever one works for you. So let's look at number 1. How do we find the area in this trapezoid? Well, the altitude is 3. Okay, then the length of one of the bases is 8. The length of the other base is 4. So the space inside of this trapezoid is going to be the altitude of 3 times the quantity of the sum of the two bases, which are 8 and 4. So we got an 8 plus 4. I'll put the plus sign here in a second. So we got 8 plus 4 divided by 2. Okay, so next, order of operations. We need to work, please excuse my dear Aunt Sally, or GEMDIS actually, grouping symbols. Then exponents, multiply, divide, add, and subtract. We want to work inside the parentheses first, so 8 plus 4 is 12. Now 3 times 12 is 36, and half of 36 is 18. So in the space inside of this trapezoid is 18 square units. Okay, we'll do another example. Number 2, to find the space inside of that trapezoid, once again, we're going to go 1/2 times the altitude. The altitude is 6 times the sum of the bases, which is 9 plus 18. Okay, so the space inside of this trapezoid, it's going to be 1/2. 9 plus 18 is 27. Half of 6 is 3. And 3 times 27 is going to give us the space inside of this trapezoid. 27 times 3, 20, 40, 60. 60, 74, 81 is 81 square units. 81 square units inside of this trapezoid. The first time we did the first trapezoid, number 1, to find the area of that trapezoid, I used one amalgamation of the area formula. When the second time around for number 2, I used the formula that is above at the top here. But both of these formulas are two and the same formulas. It's just a matter of, do we want to write it as divided by 2, or do we want to write it as 1/2 out front? Either way, the formulas are the same. Okay, now in example 2, it says find the missing dimension of the given trapezoid. So notice they're not asking us to find the area of the trapezoid. They're actually asking us to find the dimension of the trapezoid. And I notice here that we're actually missing some information, so we're going to have to edit this as we go. Or give me a quick second here. We are actually missing, we were supposed to be given the actual area of the trapezoid. So let's say we're going to say, and I apologize for that, the area of the trapezoid is 30 square centimeters. So that has to be given to us to find the actual dimension. So in example 2, it says find the missing dimension of the given trapezoid. We actually have to be given the area in that case. The dimension that they want us to find is actually the altitude of the trapezoid. Okay, so using what we know about the formula for area of a trapezoid, once again, it's going to be the altitude times base 1 plus base 2 divided by 2. So substituting in the equation what we do know, well, we know the area is 30 square centimeters. So we're going to substitute 30 square centimeters in for the area. So we're going to start out by doing that. Okay. We're looking for the altitude, so that's going to remain A for altitude, or if you want to use H for height, we're fine with that. Okay, and then the length of the bases are going to be 9 centimeters plus the length of the other base of 6 centimeters divided by 2. Okay. First and foremost, next thing we want to do is add 9 and 6. You get 15. So now what we have is 15 times A over 2. Inverse of dividing by 2 is multiplying both sides of the equation by 2. So those 2's there are going to cross cancel. 30 times 2 is 60. So now we have 60 equals 15 times A. The inverse of multiplying by 15 is dividing by 15. And we know that the altitude is going to be 4. Can't remember if that's centimeters. Let's look back up. The altitude is going to be 4 centimeters there. Okay. So the altitude is going to be 4 centimeters. So that's an example of where we actually are given the area of the trapezoid. We're working through that to actually find the missing dimension, in this case, the height of the trapezoid. Thank you for tuning in, and have a great night.